Welcome to my class 12 physics, chapter that is ray optics, and today we will discuss about image formation by spherical mirror. Spherical mirror means image formation by the concave mirror, then image formation by the convex mirror for both the mirror, and here object distance is given. That means for different object distance, what is the size of the image, nature of the image, and position of the image. We will calculate this. And first for concave mirror, and some rules are there. Rules for finding image formed by a concave mirror. And for concave mirror, total 4 rules are there, and we will discuss one by one. First rule. Suppose we take a concave mirror and their outer surface is silver coated. That means this is the non-reflecting surface, and inner surface, this one is the inner surface, and you know that is the reflecting surface. And we draw the principal axis. Suppose this one is the principal axis, and you know principal axis always passing through the pole. This one is the pole and center of curvature. Suppose this point is the center of curvature, and in between center of curvature and pole, you know focus is there. And here suppose first incident ray that is parallel to the principal axis. If incident ray is parallel to the principal axis, then what happen? And here incident ray strikes the reflecting surface at this point, so that you know this point is the point of incidence, and for point of incidence we write that is O. Then what happen? We will draw the normal to the reflecting surface at point O, and you know always normal to the reflecting surface is passing through the center of curvature. Always in case of a spherical mirror, always normal to the reflecting surface always pass through the center of curvature. So that here this is the angle of incidence. We write suppose that is theta. With equal angle, the ray is returned back into the same medium, so that the reflected ray moves in this direction and the reflected ray pass through the focus. Clear? And this is the angle of reflection, that is also theta. That means here we finally get, if incident ray is parallel to the principal axis, then the reflected ray must be passing through the focus. Clear? If incident ray is parallel to the principal axis, the reflected ray must be passed through the focus. This is the first rule. Another rule, second rule. Suppose same thing, this one is the concave mirror. Your outer surface is silver coated, and we draw the principal axis. This one is the principal axis, and principal axis passing through the pole. This point is the pole and center of curvature. This point is the center of curvature, and middle point we write that is suppose F. Clear? And here in this case, suppose incident ray moves towards the point P. That means incident ray makes an angle theta. Incident ray makes an angle theta with the principal axis. Then what happens? The ray return back into the same medium with equal angle, and this is the reflected ray, and this angle is the angle of reflection, and that is also theta. That means if incident ray makes an angle theta with the principal axis, then the reflected ray also make an angle theta with the principal axis. Clear? Then third rule. Same thing. Here also we take a concave mirror. This one is the concave mirror, and outer surface, outer surface is silver coated, and your inner surface, this one is the reflecting surface, and we draw the principal axis. So for this one is the principal axis, and you know same thing, principal axis passing through the pole, this point is the pole and center of curvature C, and middle point we write that is focus F. Clear? And here suppose the incident ray pass through the focus. If incident ray pass through the focus, then what happen? Here the ray strike the reflecting surface at point O. That means O point is the point of incidence. O point is the incident point. Then at point O to this reflecting surface, first we draw the normal, and you know always normal to the reflecting surface passing through the center of curvature. So that we write this is the angle of incidence, and with equal angle the ray is returned back into the same medium. So that we draw the reflected ray, and this one is the reflected ray, and same thing, if this is the angle of incidence we write theta, this is the angle of reflection, that is also theta. Clear? That means we get finally, if incident ray pass through the focus, then after reflection the reflected ray must be parallel to the principal axis. This is the third rule. Similarly, last rule, same thing, we also take another concave mirror. Suppose this one is the concave mirror, and the outer surface is silver coated. This is the outer surface, that is silver coated, that is the non-reflecting surface, and we draw the principal axis, and this one is the principal axis. Clear? Then this point is the pole, you know that this point is the center of curvature, and this point is F. Clear? And suppose here incident ray, suppose we take one incident ray, and the incident ray suppose pass through the center of curvature. If incident ray pass through the center of curvature, then what happen? The incident ray strike the reflecting surface at point O, then we draw the normal at point O, we draw the normal, and the normal, you know, normal is always passing through the center of curvature. That means same line, this one is the incident ray and this one is the normal, both are same, so that angle of incidence is 0. If angle of incidence is 0, then what happen? The ray return back in the same path remains same, but direction is opposite. Incident ray pass through the center of curvature, and after reflection the reflected ray also pass through the center of curvature, because angle of incidence is 0 and angle of reflection is also 0. And these are the 4 rules, and by using these rules, now we will find the position of the image formed by a spherical mirror and its nature and size. And first for concave mirror, and initially suppose object is situated at infinite. If object is situated at infinite, we write object distance, that is u is equal to infinite. If object is at infinite, that means source is at infinite, then what happen? You know, all the incident rays are parallel to each other. If incident rays are parallel to each other, we draw the incident ray. Suppose this one, the first incident ray parallel to the principal axis, and you know, after reflection the ray must be passing through the focus, so that we write this is known as the focus, this point, that is the pole, and this point is the center of curvature. Similarly, if another incident ray is there, that is also parallel to the principal axis, and after reflection the ray must be passing through the focus. That means here 2 incident rays are there, both are parallel to the principal axis, and two reflected rays are also there, and both are passes through the focus. That means at focus or at point F, both the reflected rays meet. That means at the focus, image is formed. Image is formed at focus when the object is situated at infinite. So that for position of the image, we write image is formed. Image is formed at focus, that is F. Image is formed at focus means, what is the image distance? Image distance is equal to distance between pole to the position of the image, and in this case that is PF. So that we write for image distance, we write the symbol V. V is equal to that is F, and we put that is the minus F, because this is the direction of the incident ray, and we measure P to F just in the opposite direction. So that in place of F, we also write that is the minus F if we put the sign convention. Then size of the image, look at the figure. Here both the reflected ray meet at point F, and at point F image is formed, and an image is formed means that looks like a point image. Point image means very small size. Size of the image is very small. Very small size image. Clear? Very small size. Very small size means we write that is highly diminished. That is highly diminished. Similarly, what is the nature of image? Here actually both the reflected rays meet at a point. Both the reflected rays converge with each other. That means distance between the two reflected is gradually decrease. Gradually decrease means both are converging. Both are converging means they are actually meet at a point. So that nature of image is real and inverted. Real and inverted. Clear? Then what is the magnification? We write magnitude of the magnification is equal to, magnification means that is the comparison between the size of image to the size of object, and for size of image or height of the image we write that is h prime, and for height of the object we write that is the h, and their size of image that is very small. That means a small quantity divided by a large quantity. So that magnification in this case is less than 1. Clear? That means finally we get, if object is situated at infinite, image is formed at focus in case of a concave mirror. Then second case, now we move the object. If object moves towards the concave mirror, then the second position is object is situated at this point. At this point means in between infinite and center of curvature. This is the second point. Now object is situated in between infinite and center of curvature, and we write also this point is the center of curvature. So for this one is the infinite. For height of the object we write AB, and for height of the object we write, suppose that is h, and you know this point is the focus and this point is the pole. Clear? Then we draw the incident rays. This is the first incident ray parallel to the principal axis, and you know after reflection from the reflecting surface, the ray must be passing through the focus. You know that because incident ray is parallel to the principal axis, and second incident ray is also there. Second incident ray from point B moves towards the pole, and after reflection the ray return back with the same angle same angle means, suppose this angle is equal to theta, this is the angle of incidence, this angle also theta, that is the angle of reflection. And here both the reflected rays, this is the first reflected ray, this is the second reflected ray, both the reflected ray converge with each other and meet at a point. That means image is formed at this point, and we draw the image. This one is the image. This one is the image and this is the head of the image. This is the head of the object. So that image is inverted. And for size of the image, we write that is A1, B1. Clear? Then, what is the position of image? Look at the figure. Object is situated in between infinite and center of curvature. Center of curvature means distance of center of curvature from the pole, that is P to C. PC means we write that is twice of F. That means if object is situated in between infinite and twice F from the pole, then this one is the image. Image is formed in between center of curvature and focus. So that we write position of image, that is between center of curvature C and focus F. And we write F means this is the focus, pole to focus, that is the focal length, we write small f. That means simply we write V is the image distance. Image distance is greater than the focal length and less than, this one is the center of curvature, from P to C. From P to C we write that is the radius of curvature and that is the double of the focal length, we write that is twice of f. That means if object is situated in between infinite and 2f from the concave mirror, image is formed in between twice f and f. Similarly, what is the size of image? Here, look at the figure. This is the height of the image or size of, this is the height of object or size of object. And this is the height of image or size of image. And size of image is small as compared to the size of the object. That means a small size image is formed as compared to the object. So that we write size of the image is small size as compared to the object. Small size means that is known as the diminished. Clear? Then what is the nature of image? This one is the head of object, this one is the head of image, that means image is inverted. And here both the reflected ray converge with each other and actually meet at point B1. So that is real. That means we write nature of image, that is real and inverted. Clear? That is real and inverted. And what is the magnification? We write magnitude of magnification is equal to h prime divided by h. H prime, that is the height or size of the image, that is small as compared to the size of the object. So that a small quantity divided by a large quantity, that means finally we get that is less than 1. That means finally we get if object is situated in between infinite and center of curvature, image is formed in between center of curvature and focus. Similarly, again, if we move the object again towards the concave mirror, and this is the next position. This one is the next position of the object. That means object is situated at the center of curvature. If object is situated at the center of curvature, then what happens? This point is the center of curvature, this point is the focus, and suppose this point is the pole. And object is situated at the center of curvature. This one is the object. Object is situated at the center of curvature. Clear? And for object height, we write that is AB. Object is situated at center of curvature means distance of the object from the pole, that is PC. PC means that the twice of F. So that we write U is equal to twice of F. Object distance is 2F. Then what happens? We draw the incident rays. This one is the first incident ray parallel to the principal axis, and you know, after reflection, the ray must be passing through the focus just like this. Similarly, another incident ray is there that moves towards the pole, and an angle of incidence, that is theta. With equal angle, the ray return back, and here we draw the reflected rays. This one is the reflected rays. This one is the reflected ray. Clear? Then both the reflected ray meet at this point. That means image is formed. Image is formed here. This one is the image, and this is the head of the image. This is the head of the object. For image size, we write that is A1, B1, and yet both the reflected ray converge with each other and actually meet at point B1. That means finally we get if object is situated at the center of curvature, image is also formed at the center of curvature. That means that is one case, that is only one case, position of object and image in case of a concave mirror both are same. So that we write what is the position of image? Position of image that is formed at the center of curvature C. At the center of curvature C means what is the image distance? Image distance we write that is V. V is equal to P2A1 because at point A1 image is formed. So that image distance that is P2A1 that is equal to PC and that is twice of F. So that we write that is twice of F, and we also write that is minus 2F if we put the sign convention. Next one is the size. Look at the figure. Here size of the object is the same as size of the image. So that we write same size as compared to the object. Then what is the nature of image? Look at the figure. Both the reflected ray actually meet at point B1. So that is real. And here this one is the head of object and this one is the head of image. That means image is inverted. We write real and inverted. Then what is the magnification? We write magnitude of the magnification that is h prime divided by h, and your height or size of the image is the same as the size of the object. Both are same size. Same size means we write magnification is equal to 1. Only in this case means when object is situated at the center of curvature, image is also formed at the center of curvature and magnification is equal to 1. Next, again, if we move the object again towards the concave mirror, next position of the object that is this one. This one means in between center of curvature and focus. Next one that is object is situated in between center of curvature and focus. And for object, this one is the height. This one is the height of the object. For height of the object, we write that is same thing, that is AB, and for this we write H. And an object is situated in between center of curvature and focus. Center of curvature means at a distance 2F, so that we write that is 2F. And between F means from P to F, we write that is F. That means object is situated at a distance in between 2F and F from the pole of the concave mirror. Then we draw the incident rays. First incident ray that is parallel to the principal axis, and after reflection the ray must be passing through the focus. Clear? Similarly, another incident ray moves towards the pole making an angle theta with the principal axis. With equal angle, the ray is returned back into the same medium. The ray is returned back into the same medium, and both the rays meet at this point. That means image is formed at this point, and this one is the image. This one is the image, and look at the figure. This is the head of the object, and this one is the head of the image, and both the reflected rays actually meet at this point, and these two are the incident rays. And what is the position of the image? Here object is situated in between center of curvature and focus. An image is formed beyond the center of curvature. Beyond the center of curvature means that is in between infinite and center of curvature. And for image height, we write that is A1 B1, that is H prime, and we write position of image, that is between infinite and center of curvature. Clear? That means what is the image distance? For image distance we write V. V is greater than. V means P to A1. This is V. That is beyond C. C means center of curvature. From P to C, this distance is equal to 2f. So that we write V is greater than 2f and less than infinite. Clear? That means if object is placed in between center of curvature and focus, image is formed beyond the center of curvature. What is the size? Look at the figure. This one is the height of object. This one is the height or size of the image. That means a large size image is formed as compared to the image. Large size image means we write that is a magnified image. Size of the image is magnified. That means a large size image is formed as compared to the object. A enlarged image is formed. What is the nature? This one is the head of the object. This one is the head of the image. So that image is inverted. We write image is inverted. And again, both the reflected rays converge with each other and they actually meet at point B1. So that is real. That means finally we write nature of the image is real and inverted. And what is the magnification? We write for magnification, magnitude of the magnification, that is H prime divided by H. H prime in size of image in this case is greater. That means a large quantity divided by a small quantity, so that magnification is greater than 1. Clear? That means we get when object is situated in between center of curvature and focus, image is formed beyond the center of curvature. Again, if we move the object again towards the concave mirror, and this is the next position of the object, that is at the focus. If object is at the focus, then what is the position of the image? Object is situated at the focus. This is the focus. Object is situated at this point. And this one is the object. And for object height, we write that is AB. Object is situated at focus. Then what is the object distance? Object distance is equal to P to F, that is U. U is equal to F. So that we write U is equal to F. Then we draw two incident ray. First incident ray, that is parallel to the principal axis. And you know, after reflection, the ray must be passing through the focus. This one is the first incident ray, and this one is the first reflected ray. Similarly, another incident ray is there, moves towards the pole with angle of incidence, we write suppose theta, and with equal angle the ray is returned back into the same medium. So that we draw the reflected ray. This one is the reflected ray. Clear? And this is the angle of reflection, that is also theta. And look at the figure. Here both the reflected ray are parallel to each other. If both the reflected ray parallel to each other, image is formed at infinite distance. Image is formed at infinite, and that is the position. Position of image we write simply at infinity. Clear? That means we write V is the image distance, that is equal to infinite. If object distance is equal to F, image distance is equal to infinite. That means if object is situated at focus, image is formed at infinite. Then what is the size of image? Here both the rays actually meet at infinite. At infinite means image size that is highly magnified. That means a very large size image is formed. And what is the nature? Here both the reflected ray actually meet at infinite. Actually meet at infinite means that is real and inverted. And what is the magnification? We write magnitude of magnification, that is h prime divided by h. H prime means size of the image, that is highly magnified, that means a very large size image is formed. A large size image is formed means a very large quantity divided by small quantity. So that magnification is very greater than 1. Clear? Next, again, if we move the object towards the concave mirror, then what happens? The new position of the object is in between focus and pole. Focus and pole, and up to focus, always we get real and inverted image. Up to focus, up to infinite to focus, we get one type of image, that is real and inverted. But when object is situated in between focus and pole, image is not real and inverted. Image is virtual and erect. How? Object is situated in between the focus and the pole, and this is the position. This is the position of the object, that is in between focus and pole, and for object height we write that is AB. And here also same thing, we draw two incident rays. First incident ray, that is parallel to the principal axis, and after reflection, you know, the ray must be passing through the focus, this one. Similarly, another incident ray is there, that is moves towards the pole, and after reflection, the ray moves into the return back into the same medium, this one. That means here, this is the angle of incidence, we write suppose theta, and this is the angle of reflection, we write that is the theta. And look at the figure here, both the reflected ray diverge with each other, that means distance between the two reflected rays is gradually increased. Distance between the two reflected rays gradually increased, that means both the reflected ray cannot meet in this side, so that we extend both the rays, we extend both the reflected rays in the backward direction. If we extend both the reflected rays in the backward direction, this is the first reflected ray, and we extend the reflector in the backward direction, similarly the second one, and both the reflected ray suppose appears to meet at this point, so that the final image is formed. Image is formed at this point, and this one is the image. For image height, we write that is A1, B1, and that is H prime. Clear? And look at the figure. Object is situated in between focus and pole, that means in front of the concave mirror. An image is formed just behind the mirror, that means what is the position of image? We write position of the image is behind the mirror. Then what is the size of image? This one is the size of image. That means a large size image is formed. A large size image is formed as compared to the object, and that means that is a magnified image. Image is magnified, a enlarged image is formed. What is the nature? Here both the reflected ray appears to meet at point B1. Appears to meet means these rays are not real one. So that nature of the image not real means we write that is virtual. And look at the figure. This is the head of the object. This one is the head of the image. Both are in the same side. Both are in the same side means not inverted. Not inverted means we write that is erect. Not inverted means we write that is erect. Then what is the magnification? Magnitude of the magnification is equal to h prime divided by h. Here size of the object is this one. This one is the size of image. Image size is greater as compared to the size of object. So that a large quantity divided by small quantity, that means magnification is greater than 1. Clear? Clear? Once again, in case of concave mirror, suppose this one is the concave mirror and this side is the reflecting surface, this side is the reflecting surface, and back side, that is the coated with silver, and this is the non-reflecting surface. And we draw the principal axis. Suppose this one is the principal axis. Suppose. Clear? Then this point is the pole, we write P. This point is the suppose focus F. This point is the center of curvature. And here, suppose object is situated at infinite. If object is situated at infinite, image is formed at focus, you know that. Again, if object is situated in between infinite and center of curvature, if object is situated in between infinite and center of curvature, image is formed in between center of curvature and focus, that means a small size image is formed. If object is situated at the center of curvature, then image is formed at the center of curvature with the same size. Clear? Once again, if object is situated in between center of curvature and focus, suppose this one is the position of the object, then image is formed beyond the center of curvature. A large size image is formed. Clear? Again, if object is situated at focus, then image is formed at infinite. Again, if object is situated in between focus and pole, then image is formed just behind the mirror, and a large size image is formed. And this one is the first case. Object is situated at infinite, image is situated at focus. This is the second case. Object is situated in between infinite and center of curvature, image is formed in between focus and center of curvature. This is the third case. Object is situated at the center of curvature, image is formed at also center of curvature. Next, object is situated in between center of curvature and focus. This is the fourth case. Image is formed beyond the center of curvature. Next, if object is situated at focus, that is the number 5, image is formed at infinite up to this point, up to number 5. If we move the object from infinite up to focus, then image is also moved away from the mirror. If object is moved towards the mirror up to focus, image is formed away from the mirror, and here size of the image is gradually increasing. And if object is situated beyond the or in between focus and pole, in between focus and pole means this is the number 6 case, image is formed just behind the mirror. And this is all about your image formed by a concave mirror. Next one, that is the convex. Next one, that is image formed by a convex mirror. And here also rules are there. Rules for obtaining image formed by a convex mirror. 2 rules are there. First rule. Suppose we take a convex mirror. This one is the convex mirror. Here something different. Something different means inner side is silver coated. This side is the non-reflecting side, and outer surface is the reflecting surface. And you draw the principal axis just like your concave mirror. This one is your principal axis. And in case of convex, just in this side, in right side, focus is there, and center of curvature is there, and this point is the pole. Suppose one incident ray is there, and that is parallel to the principal axis. If incident ray is parallel to the principal axis and the incident ray strike the reflecting surface at point O. That means point O is the reflecting surface. Then what happened? We draw the normal to the reflecting surface, and you know, normal to the reflecting surface always passing through the center of curvature. Always passing through the center of curvature. Always passing through the center of curvature. This is the normal. This one is the normal. So that this is the angle of incidence. Suppose that is theta. With equal angle, the ray is returned back into the same medium. So that we draw the reflected ray. This one is the reflected ray. This one is the reflected ray. Clear? And this is the angle of reflection. We write that is theta. Then, if we extend the reflected ray in the backward direction, the ray appears to meet at focus. The ray appears to meet at focus. That means if incident ray is parallel to the principal axis, after reflection, the reflected ray appears to come from focus. Clear? Similarly, another rule is there. Second rule. Suppose this one is your convex mirror and the inner surface is silver coated, that is the non-reflecting surface, and we draw the principal axis, and suppose this one is the principal axis, and same thing, this point we write that is pole P, this point that is the focus, and this point that is the center of curvature. Clear? And here incident ray, suppose making some angle theta with the principal axis, this is the angle theta, then what happened? The ray return back into the same medium. And this is the reflected ray. And this angle is also theta. This is the incident ray. Clear? That means if incident ray makes an angle theta with the principal axis, then the reflected ray also make an angle theta with the principal axis. Clear? With these two rules, now we will discuss the image formed by a convex mirror. And first case. Here position of the object is at infinity. Suppose the object is situated at infinite. If object is situated at infinite, then you know all the incident rays are parallel to each other. And this one is the first incident ray, parallel to the principal axis. And you know, after reflection, the ray appears to meet at the focus. So that we draw the reflected ray. This one is the reflected ray. Clear? Similarly, second incident ray, that is also parallel to the principal axis, and after reflection, again the reflected ray appears to meet at a focus, and we draw the reflected ray. This one is the reflected ray, and this one is the second reflected ray, this one is the first reflected ray, and these are the incident rays. And here this one is the pole, this one is the focus, and this one is the center of curvature. Look at the figure. Here distance between the two reflected ray after reflection is gradually increased. Gradually increase means both are diverge. If both are diverge, then what happen? We extend both the reflected ray in the backward direction. That means both the reflected ray appears to meet at focus. Appears to meet means that is not real. Not real means virtual. Then what is the position of image? Object is situated at infinite and image is formed at focus. We write image is formed at focus. For image distance we write V is equal to F. If object is situated at infinite, image distance is focal length. Then what is the size of image? Here image is formed at focus, that looks like a point image. point image means that is very small size. Very small size. Very small size means highly diminished. Highly diminished. What is the nature of image? Here both reflected ray diverge with each other. Diverge with each other means we extend both the reflected ray in the backward direction. So the nature of image, that is virtual, not real. Virtual and erect. And what is the magnification? Magnitude of magnification is equal to, you know, that is the size of image divided by the size of object, and your image is a very small, that means a very small quantity divided by a finite quantity, so that is very, very less than 1 in this case. And another case, and the last case here, object between infinity and pole. If object between infinite and pole, we write this point is the pole. This is the infinite. Object is situated in between infinite and pole. Suppose this one is the size of the object. For object size, we write that is AB. Clear? And for this, we write that is H. This point is the focus. This point is the center of curvature. Here also we draw two incident ray. This one is the first incident ray parallel to the principal axis, and you know, after reflection the ray appears to meet at focus, and we draw the reflected ray. This one is the reflected ray. Similarly, another incident ray meet at point pole, and the reflected ray moves in the same medium. And if we extend the reflected ray, second reflected ray in the backward direction, both the reflected ray meet at this point. That means image is formed at this point. And for image, this one is the image. And look at the figure. This is the head of the image, and this is the head of the object. For image, we write that is A1, B1. Head situated in the upside. Here also head situated in the upside. That means both are not inverted. Not inverted means we write that is erect. And these rays are not real. Not real means we write that is virtual. Virtual and erect. That means in case of convex, always virtual and erect image is formed. No real image is formed in case of a convex mirror. And what is the position? Here image is formed in between pole and focus. So that we write image is formed between image is formed, or we write in between, that is pole and focus. Image is formed between pole, P for pole, and for focus we write that is F. Clear? What is the size of image? Look at the figure. Image size is small as compared to the size of the object. So that we write a small size. A small size means diminished. A small size means a diminished image is formed. And what is the magnification? For right, magnitude of the magnification, that is H prime divided by H. Here size of the image is small as compared to the size of the object. So that a small quantity divided by a large quantity, that means that is less than 1. Clear? That means in case of a convex mirror, always a small size image is formed. And here also same thing. If object is situated at infinite, image is formed at a focus. And if we move the object from infinite towards the convex mirror, image is also moves towards the convex mirror. And here always image is formed behind the mirror. Behind the mirror means image cannot be obtained on the screen only in case of convex mirror. But in case of concave, this one is the case, only in this case virtual and erect image is formed. That means here also image cannot be obtained on the screen when object is situated in between focus and pole. But in all other cases, in case of convex, real and inverted image is formed, just like this. Here also real and inverted image is formed, and here also real and inverted image is formed, and here also real and inverted image is formed, clear, and here that is also real and inverted, and here that is also real and inverted, clear. And this is all about your image formed by a spherical mirror. And in the next class, we will discuss about mirror equation.